Hi everyone, and welcome to this short ACM fact recording of It's Just Not That Simple, an empirical study of the accuracy-explainability trade-off in machine learning for public policy. And this work was done by myself, Andrew Bell, Ian Renee Solano-Kamaiko, Dr. Oded and Dr. Stoyanovich, all of us at NYU. And so it should come no surprise to the audience of this presentation that over the last decade there has been a rapid proliferation of AI and ML into the public and private sectors. And with this, practitioners have been increasingly using complex, opaque models known as black box models, which can lead to misuse or accidental risks. And along the right side of the screen here are several examples of news articles highlighting the ability or the possibility of AI and ML algorithms to have racially or gender biased outcomes. And this is in part due to a lack of transparency into how these systems work. And so as a result, there's been this explosion in the field of explainable artificial intelligence, or XAI, where researchers are trying to understand how well a human can understand AI. And there's been a number of tools that have been developed like Line, QII, SHAP, and SAGE that have been able to sort of open up black boxes. But there's also been this issue of the accuracy-explainability trade-off, or this idea that as model complexity increases, explainability decreases, but accuracy increases. And there's really been in the ML community two sides to this coin. Those that believe that black box models are consistently outperforming simpler models, and then those that say things like just fit a logistic regression. And there's actually case studies that we cite in the paper that support both examples of this, so that there is a trade-off and that there isn't a trade-off. And so we set out to try and quantify, fill the research gap and try and quantify this trade-off between accuracy and explainability. And so we did this by coming up with a method for measuring explainability by taking some ideas from human-computer interaction and having a set of users complete tasks and answer questions. And we did this, created this measure that includes a mix of objective tasks and subjective tasks. Things like, can users anticipate the output of a machine learning model? Can they identify the most important feature of this machine learning model? And then also kind of measuring their own perceived system understanding and perceived system confusion. And as a result, we found some pretty counterintuitive results. One of our key findings of this paper is that we actually found no statistically significant difference between black box and interpretable models on these decision tasks. And in the paper, we also break this apart and go into four-way model comparisons and talk about some of the differences and propose deeper theories. But some of our ideas come from this idea first of like weaknesses in what was thought to be explainable models. So first of all, when it came to like the decision tree, users were very confused on understanding how the nodes of the decision tree maybe translate to something like feature importance. So they had trouble identifying the most important feature. We also picked up on this idea of user confusion, which seems to bifurcate our users. There's those that are very confused and those that are not confused, and it does translate to actual performance on these tasks, differences on these tasks. And one of our ideas is that this might actually be due to information overload when they're seeing something. Users are seeing things like SHAP plots or linear regression formulas or decision trees, but more study is needed in this direction. We also found that when it came to performance on a number of different metrics in both of the domains that we studied, education and housing, that there was a lot of tie on performance, and that it seems that black box and interpretable models actually are performing at similar rates. So when we put it all together, we kind of get this idea that it's really not easy to generalize the accuracy-explainability trade-off, and that there are cases where it seems that black box models outperform, and there's cases where interpretable models perform similarly with respect to accuracy and also with respect to explainability. And so we kind of end the paper with some recommendations for practitioners, kind of cautioning against trying to generalize. We also challenge some commonly held beliefs about the inherent interpretability or the inherent explainability and accuracy of these models. And we also present some design considerations, like, for example, looking out for weaknesses in things like the decision tree diagram or perhaps the linear formula that individuals should be aware of when implementing these models. And then we conclude with advocating for interdisciplinary collaboration between ML engineers, domain experts, end users in order to effectively implement these types of explainable ML systems. Thank you, and we look forward to hearing questions that you might have.